Okay, we've started to build our drag racers. We've started to look at gears. We need to figure out what is the best gear ratio for our drag racer. So as we look at the gears that I have here, I want to show you how to identify the gears or how to name the gears, and I want to show you how to figure out gear ratios. So the gears are actually named by the number of teeth that are on them. And so in our Lego kit, we have a 40 tooth gear. You just rate 40T as the largest. This one is a 36 tooth gear. These two here, are 20 tooth gears. This one is a 24 tooth gear. This one here is a 12 tooth gear. And these tiny little ones here are 8 tooth gears. So that's how we name all of the gears. And what I see is that a lot of students are using the 36 and the 12. So let's go ahead and take a look at that. I'm going to take a beam and I'll just pop the 36 tooth gear on there. I'll take another pin axle and I'll put the 12 tooth gear on. So I've got the 36 and the 12. And it's really hard to count. But if you were to look very closely at one of these teeth and watch how many times it turns around when I turn this one around once. The large gear is a little easier to see because I can put a little marker in there. Okay, but just try to find a spot. If this wasn't black, I could draw on it. Find a spot and watch it go around. It'll go really slowly. Yeah, it's really hard to see. Gotta go super slow. Oops, getting caught a little bit. And back to the beginning. If you didn't see that, you can try it yourself, but the smaller gear turned around 3 times when the large gear turned around 1 time. Let's see if we can figure out what that all means or how we got there. The way that we do this is pretty simple. We make what's called a ratio. You take your 36 and you can write the ratio like this to 12. And what we want to do is we want to take that ratio and reduce it. So we ask ourselves, is there any number we can divide both of these by? And the answer is, I could divide 36 by 12. I could divide 12 by 12. 12 goes into 12 1 time. 36 divided by 12 is 3. My new ratio then becomes 3 to 1. That's a ratio of size. This 36 tooth gear is 3 times bigger than that 12 tooth gear. But what that means is for every 1 time this gear turns around, that one will turn around 3 times. So we're basically making this go 3 times as fast. So when you have this set up on your drag racer like this, 36 to 12, your drag racer is going 3 times as fast as the motor is turning, which is pretty good. That's not bad at all. Hold on a second, let me switch pages and we'll do this again. Okay, let's try this with another set. And this last time I used the 36 and 12, and you notice these are a bit thicker than these other gears. You know, these gears over here don't play well with these gears over here. And that's okay. You have to keep trying different combinations until you get the one that makes your drag race the fastest. So I'm going to take a beam, and I'm going to take this 24 tooth gear and one of these 8 tooth gears. And so if I look at my ratio, I want my lead gear to be the larger one, so 24 to 8. Can anybody see a number that you divide both 24 and 8 by? 8. 8 divided by 8 is 1. 24 divided by 8 is 3. So again, just like with this one, I got a 3-to-1 ratio, which means for every 1 time this turns, the little one will turn 3 times. So using this setup here isn't any better than using this setup here. But I'm going to tell you that there is a combination out of all the gears here that gives you the best ratio for your drag racer. There are 2 gears here that you could mesh together to end up with a 5-to-1 ratio. That would make your drag racer go 5 times faster than the motor's turning. I'm going to ask you to play with your gears and to figure out which are the 2 gears that can mesh together to give you a 5-to-1 ratio. And if your table can find them, that's the one that you're going to use to make a super fast drag racer. I can't do art.